So, in continuing our discussion about determining proportionality, we're going to begin to look at data that may be presented in other forms beyond ratios or rates being compared to each other. So, the top two problems actually are nothing more than a review of material we've done already. So, I'm going to have you quickly confirm whether these two rates compared to each other are proportional by cross multiplying. And likewise, do the same here. Now, don't forget, these could either be ratios or rates without knowing the units. We just don't know. So you may just hear me say rates as my default all the time. One last thing to remember, don't forget that when we see something in word form that I probably want to rewrite these accordingly. So that word two, just like the word per, is like a fraction bar. So this really means 0.75 over 210. This means 0.15 over 42. And now you're ready to do your quick cross multiplying. So you'll do that here. 8 times 25 compared to 14 times 15. Likewise, you'll do it here. 0.15 times 210 and compare it to 0.75 times 42. And you know, if you get the same cross product, it is a proportion. If you get a different cross product, it's not a proportion. So those two are quickly for review, which you'll do on your own, but we'll continue on with the other content of the video from here otherwise. So what we need to realize, as I mentioned, is that data isn't always presented to us in forms of ratios or rates. So we need to start getting used to the fact that data is more often than not presented as ordered pairs, as you see here in both examples, or in table form, either a horizontal table or a vertical table, or data can be presented in the form of a graph. And we want to know how to apply a simple test to data presented in any of these forms so we can quickly determine if we're looking at a proportion or not. So in the first two examples with ordered pairs and tables, it's essentially the same test. We're going to be establishing a ratio from the data, comparing y to x in every case, comparing y to x for every piece of data. And if that ratio is the same for every piece of data, we have a proportion. And if it's not the same in all cases, meaning we just have one ratio that doesn't fall in line with all the others, then it's not a proportion. So the only time we will disregard that is with the origin. So you're going to see here the origin is kind of an excluded value. So when we get to doing y over x, if we ever come across the origin, just skip it, because mathematically you can't do a ratio, or you can't calculate 0 over 0. So let's quickly take a look. In my first set of data, don't forget, with ordered pairs, and as a reminder with ordered pairs, they're always made up of an x coordinate and a y coordinate. The x always coming first, followed by the y. So maybe we just go ahead and mark x and y accordingly over all of our values, because that will be a good reminder for us as we begin to set up our ratios, because I want to make sure that every time I set up a ratio, that it is my y value, in this case 24, over my x value of 18. Again, when I go to the next ordered pair, it is my y value, my second coordinate, over my x value, my first coordinate. And you'll see me do that in all these cases. Now, all we're going to do is actually leave these in fraction form. You're going to understand that there is a value to seeing these ratios, this ratio of y over x, in fraction form, particularly when we get to graphing. So all I'm going to do is to see if each of these reduces down to the same simplified ratio. So I want to be able to reduce each of these and compare in their fully reduced form. That means we're going to have to reduce either in smaller pieces of common factors, or ideally recognize the greatest common factor. So I'm going to, as I go through, I'm going to reduce these by what I know to be the greatest common factor. So for example, I know the greatest factor I can reduce 24 and 18 by is 6. And when I do that, I get 4 over 3. Likewise, when I move on to the next one, I know my greatest common factor of negative 44 and negative 33 is 11. And one more time, I get 4/3, or 4 to 3. Again, I want to read that as a ratio. Now, so far, we have a match. If these were the only 2 points that we were comparing, then I know I would be proportional. But I have 4 ordered pairs, and I have to see that all 4 would reduce down to this. In the next example, I know our greatest, or in the next ordered pair is a ratio of y over x. I know our common factor, greatest common factor is 15. And one more time, so far so good, we get a reduced ratio of 4 to 3. And in our last ordered pair, if we look closely enough, we see the greatest common factor is 8. And one last time, I get 4 to 3. So if we follow the rule, we test all by comparing a ratio of y over x, which we did. And if we get the same value every time, which we did, then I know this is proportional. So you'll go back and you'll do that one more time for the next set of ordered pairs, and you'll exclude the origin. So you're going to compare y over x, set up the ratios and see if they reduce down, and see if they do match, you get a proportion. If they don't match, you don't get a proportion. Now that's going to be the same exact test that we apply to a table, but with the table, we just want to know how to pull the data apart and think of it as ordered pairs. So in this horizontal table, it's clearly marked, and this will always be the case. Our top row is x, and our bottom row is y. So when I go to set up y over x, I just have to be careful because the y being our bottom row value in our ratio, it has to turn out to be the top value. So I'm going to say y over x is 8 over 1. And I'm going to compare that to the next piece of data in the table, our y value 20 over our x value of 2. And likewise, 32 to 3 and 44 to 4. So you'll do that ratio, and if these all reduce down to the same value, one more time, you'll know you have a proportion. If they don't reduce down to the same value, you don't have a proportion. So you're noticing that the test is identical to the ordered pair test. You just need to know how to convert the data accordingly. So horizontal tables, top row is always x, bottom row is always y. Vertical tables, like we see here, we have 2 columns. The left column is always x, and the right column is always y. So I'm going to do my y over x here, and I'm going to realize my y of 3 over x of 2 is representing the cost of $3 in relation to the number of tickets being 2. And I can do the same ratio, 6 to 4, y over x. And I can compare it 9 to 6, y over x. I can compare it 12 to 8, y over x. And I can compare it to 15 to 10, y to x. Just to demonstrate, you'll notice all of these actually reduce down to 3 to 2. So what does that tell us? All of these reduce down to 3 to 2. We know that is a proportion. So you'll apply that test over here to see if you get the same type of outcome. So once again, when you have a table or when you have ordered pairs, it's essentially that y to x comparison. And if you get the same result every time, it is proportional. If you don't get the same result every time, it's not. Moving on to the last way we can see data represented, well, it would be graphically. Now, to understand, I could take all of these ordered pairs and graph them in a coordinate plane or plot them in a coordinate plane. I could do the same with this group of ordered pairs, plot them in a coordinate plane. I could do that even with this data, thinking of the data as ordered pairs and plot either the data for this table or plot the data in this table. Now, if I were to look at that graph data, anything that would be proportional would pass 2 simple tests. First of all, the graph would have to be linear, which just simply means it forms a straight line. So when I look at a graph, if it forms a straight line, that's the start to determining something's proportional. But if it also passes through the origin, that's the other key point. So real quick, you look at this first graph, it is linear, it forms a straight line, but it does not pass through the origin. So this is not a proportion. Here, it is a straight line. I can see that straight line here. It does pass through the origin, so that is a proportion. So what I like about graphs is that they're nice and easy. They give us the easiest visual model for determining. There's very little work involved. Just look for whether we have a straight line that already goes through, or it can be predicted to go through the origin, and you'll quickly know if you're proportional or not. So that is our summary of testing for proportionality. And this is going to be really helpful in laying the groundwork for writing equations and for graphing lines from here.